पास नहीं है, बाहर जाएगा तुरंत बाहर।
स्टूडेंट्स बैठ जाओ तुम लोग और एकदम आराम से सुनना। अभी थोड़ी देर में हम लोगों से डॉक्टर विकास मित्तल सर NIT कुरुक्षेत्र से कनेक्ट होंगे। और जो ये कॉन्फ्रेंस चल रहा है इसमें जो टॉपिक्स हैं, जो सस्टेनेबल एनर्जीज के बारे में या फिर इमर्जिंग टेक्नोलॉजीज हैं या फिर आर्टिफिशियल इंटेलिजेंस सिस्टम्स के बारे में, उन पे उनका एक बहुत ही अच्छा एक की नोट स्पीकर भी है और बहुत अच्छा वो लेक्चर भी देंगे। तो ध्यान से सुनना है, स्पेशली यहाँ पर कंप्यूटर साइंस या IML और CS के जितने भी स्टूडेंट्स हैं या अदर ब्रांचेस के भी जो स्टूडेंट बैठे हैं उन सबके लिए बहुत ही बेनिफिशियल सेशन होने वाला है। तो थोड़ी देर में बस कनेक्ट हो रहे हैं सर। उस बीच में कोई भी स्टूडेंट किसी भी तरीके का कोई शोरगुल या आवाज या अंदर बाहर नहीं होंगे। आप जहां पर आप बैठे हैं वहां पर आप अपनी सीट पर बैठे रहेंगे। सर कनेक्ट हुए? कनेक्ट सर। वेरी गुड आफ्टरनून सर, डॉक्टर विकास सर। कैन यू हियर मी सर? Sir, we are not getting your voice. Hello, Vikas sir, are you there? डॉक्टर विकास सर, क्या आप हमारी आवाज सुन रहे हैं? सर प्लीज अपना माइक ऑन करें सर। जब कनेक्ट हुए हैं तो बताइए। माइक ऑफ है। माइक ऑफ है। डॉक्टर विकास सर, माइक ऑफ है। जो स्टूडेंट्स यहाँ पर अभी ज्वाइन किए हैं उनके इंफॉर्मेशन के लिए बता दें बेटा, ये इंटरनेशनल कॉन्फ्रेंस है ऑन इंटेलिजेंट सिस्टम, सस्टेनेबल इंजीनियरिंग एंड इमर्जिंग टेक्नोलॉजीज पे। ये बड़े गर्व की बात है कि आपका KIPM कॉलेज इस तरह के इंटरनेशनल कॉन्फ्रेंस को ऑर्गेनाइज कर रहा है और आप बहुत लकी हैं, चाहे फर्स्ट ईयर के स्टूडेंट हो या सेकेंड ईयर या थर्ड ईयर के, जो आप इस इतने बड़े कॉन्फ्रेंस के हिस्सा बनने जा रहे हैं और आपका कॉलेज ये ऑर्गेनाइज कर रहा है। आपके कॉलेज के लिए, आपके लिए, इस ईस्टर्न यूपी के लिए, ईस्टर्न यूपी में जितने भी इंजीनियरिंग कॉलेजेस हैं उन सब के लिए बड़े गर्व की बात है कि अभी थोड़ी देर में, आज से कल तक में, ये 2 दिन का कॉन्फ्रेंस है। इस 2 दिन में हमारे साथ इंडिया के ही नहीं, फॉरेन के भी बहुत से फैकल्टीज, रिसर्चर्स, इंडस्ट्रियलिस्ट, टीचर, वो सभी लोग हम लोगों से कनेक्ट होंगे। तो ये 2 दिन आप लोग के लिए बहुत अच्छा होने वाला है। आपको जब भी बुलाया जाए तो आप टाइम से आकर के यहाँ पर बैठिए, ये आपके बहुत फायदे का होगा, क्योंकि आप लोग को बीटेक में भी आगे चल करके ये बहुत अच्छा होगा कि आपको बता सकेंगे कि आपको यहाँ पर इंटरनेशनल कॉन्फ्रेंस को अटेंड कर चुके हैं। ये एक अचीवमेंट होगा आपके, ये आपके बायोडाटा में भी कॉन्फ्रेंस को यहाँ पर आपने अटेंड किया है, ये बड़े ही गर्व की बात आपके लिए होगी। तो आप लोग इसको ध्यान से अटेंड करिए, इसकी इंपॉर्टेंस, इसकी वैल्यू को जरूर समझिए। अभी थोड़ी देर में एनआईटी कुरुक्षेत्र से डॉक्टर विकास मित्तल सर यहाँ पे हम लोगों से जुड़ेंगे और अपना वो पूरा का पूरा यहाँ पर प्रेजेंटेशन देंगे।
Very good afternoon.
गुड आफ्टरनून सर, डॉक्टर विकास सर, क्या आपको मेरी आवाज आ रही है सर?
हाँ जी, should I start?
Very good afternoon sir.
Very good afternoon.
KIPM College welcomes you sir. My dear students, Dr. Vikas sir is connected with us. मैं इनसे इनके प्लेनरी स्टार्ट होने से पहले मैं इनके बारे में थोड़ा सा आप लोगों को बता दूं। Dr. Vikas Mittal sir, it is my pleasure to introduce, is an associate professor in the Department of Electronics and Communication Engineering at National Institute of Technology NIT Kurukshetra, an institute of national importance. He holds a B.Tech and M.Tech in Electronics and Communication Engineering from REC Kurukshetra and a PhD from NIT Kurukshetra awarded in 2017. Dr. Vikas Mittal sir has around 28 years of teaching experience and has contributed extensively to research with 50 plus journals and conference publications, 3 granted patents, 22 plus expert lectures, and supervision of PhD and M.Tech research scholars. His major research interests include signal and image processing, satellite image processing, image data fusion, biomedical signal processing, renewable energy sensors, and cyber physical systems. He has also served in several important academic and administrative roles, including head of the departments of Electronics and Communication Engineering, and is currently associated with the Computer Center Simulation Lab at NIT Kurukshetra. He has also been the principal investigator of a rupees 21.39 lakh DRDO sponsored project on data fusion algorithm for vehicle detection and classification system. आप लोग एक बार इनके लिए ताली जरूर बजाएं। थैंक यू सर, आप स्टार्ट कर सकते हैं सर। थैंक यू वेरी मच।
Very good afternoon. Thank you. Thanks a lot for giving the brief bio of brief introduction to me. Some of the data is old, right? Like I have got 5 patents, 100 plus papers, right? By now, and I think this information you have taken that was given by me previously. So, anyways, first of all, I would like to convey my thanks to the organizers of this conference. And when I was browsing through the brochure of the conference, I was very much, you can say, convinced that it is going to be a good exercise, good interaction, or good opportunity for the delegates to interact from different disciplines, right from the humanities to mechanical, electrical, electronics, and things like that. So it is a very good theme and a good effort by the organizers, and thanks for inviting me to give me an opportunity to interact with the delegates and all the. So when I was given an invitation to deliver this keynote address, I was a little bit confused that on which topic should I speak. So I just went through the Am I audible?
Yes, sir. Yes, sir.
Okay. So then I thought that, okay, let me just a minute, please. So this was, so I was a little bit confused that on which topic should I speak. And then I found went through the brochure of the conference and then have an idea that let's speak on the current scenario of engineering research, that where we have to like talk about the multidisciplinary approach. So that's why I came up with this idea. And now I will just have a brief presentation and convey my some ideas, share my ideas with you. And then later on, after the end of this presentation, I'll be happy to take some of the queries of those present in this session. So if you look at the things today, my PPT is visible to everybody, please confirm. Please confirm that this PPT is visible to everybody. Is it visible?
Yes, sir.
Okay. So when we talk about the research in engineering, and this is very a good topic that you have selected, good theme that you have selected for your conference, because nowadays that when the isolation, engineering cannot happen in isolation. Like if you look at the things, uh, like we are talking about Atmanirbhar Bharat, right? We are listening to this term so many times, and we are also listening to the term Viksit Bharat, right? That may happen in say 10 decade from now on. So these things are coming up now. Why these things are coming up? Reason being that we have to shift from just the theory or the publications to an approach where the manufacturing is required, production. And whenever we talk about the production, or we can say that we have to bring a system into its reality, realize a system. This is what is the need of the hour. And when we have to realize a system, am I audible, please? Because in online, right, you have to keep on confirming.
You're audible, sir.
Okay, very good. So this is when we want to realize a system, then you know that when a system is there, it cannot have the components or the approach skills right from only one domain, right? Like for example, if you talk about nowadays, if you happen to see when you browse your internet or the Google feeds, RSS feed, and other things on the social media, YouTube and something like that, you will find that lot of robots are being shown nowadays from some company in China, and they are being shown to sorting the dark post, right? In the post office, they are shown to play some football, some games. They are shown to walk on different terrains. Then we have got another development that we have seen. It is been shown to us that we can realize any robot as a humanoid with your face, right? With the face of anybody of us, right? And then it will provide you a company. It will be a companion to you. Okay. So it is just like a friend next sitting you with your face, right? So if the idea behind this is that if somebody dies and then we can have a humanoid robot in his place, in his or her place, and then that may like overcome the shortcoming of the absence of that particular person. So this is the idea. Now, in this case, like if you have seen the humanoid, I think everybody, please, it would be nice that if you confirm that whether you have seen this or not on the social media. May I like have some voice from some of the participants? Have you seen some of the humanoids on YouTube videos or something like that? Pardon?
Yes, sir.
Okay. So when we happen to see this kind of thing, so you see that in a making of a robot, you need different kind of skills, right? Like it needs some mechanical information, also mechanical skills. It also needs some electronic skills, computing skills, right? Programming skills. So basically, when you want to create a system, this is one example I have given. I will just talk with a case study also later on. So when we talk about these kind of realizations, realizing a system, any system, it could be like from different domains. You talk about electric vehicles nowadays, right? When we are talking about the electric vehicles nowadays, you see that it is less of a mechanical, more of a electronics. You see any of the vehicles nowadays. You talk about the cars. Let like we should not talk about like autonomous vehicles. Even below that, the normal vehicles that we see around us, right? A normal vehicle, petrol engine also, diesel engine also, but a lot of electronics is there, right? And nowadays it is advanced driver assistance system, ADAS, that you also have seen somewhere or must be heard about this thing. So basically what I'm trying to say is that no longer the mechanical engineers are required in the automation automotive industry. They require electronics engineer also, they want electrical engineers also, they want computer engineers also. So this is the call of the day, need of the hour, right? So whenever we want to have some innovation, like this is the next phase, and for the next 2 decades at least, we'll be seeing these kind of developments, innovations, and that's why I have written here driving next generation innovation through cross-disciplinary collaboration. Okay, so basically, like earlier, I happened to see in my department also, we say that okay, these are the persons from signal processing, these are the persons from belonging to communication group, these are the persons belonging from VLSI group. So these things are nowadays immaterial, because when we talk about VLSI, right, they have to make the circuits, design the circuits for other technologies like communication, signal processing. They have to design the signal processing processors. They have to design the like communication chips. So, and that is also in line with the government mission. Nowadays, you must have heard about semiconductor mission. So this is just the realization. Any chip is a system, right? If you like look around a chip, chip means IC, integrated circuit, and when you see an IC, this is also a system because it has got some input, output, and it is doing some dedicated approach. So we can have some ASICs also, application specific integrated circuits. So basically what I want trying to say is that nowadays you cannot call yourself to be, of course, there is a specialization in a particular domain, but you need so many other things also alongside so as to realize the system, right? So this is the central idea that I will talk about today in front of you. So that's why I kept the title of my talk as multidisciplinary approach for research in engineering and technology. So this is a, as I've told you, in modern engineering, this is a paradigm shift. Paradigm means that there's a philosophy is changing, right? There's a need, and that is also, and that is the, you can say, the skill set also required for you to keep you as a relevant. And if I talk for the students, it is just for getting the jobs in the industry, right? Merely the knowledge of one thing will not be able to like keep you surviving in the ocean of the industry, in the job market. And you have to like keep on updating yourself continuously. Like everybody is listening nowadays that it is an AI. You must have seen somewhere the news that artificial intelligence is taking a toll on computer engineering students, computer engineering students, computer engineering students, and these software developers nowadays, they are losing their job. They are on the verge of losing their jobs because of the emergence of AI, artificial intelligence. So these kind of things we happen to see, but this does not mean that the jobs are losing. What we are looking at is that these jobs are the shift in the philosophy. The focus is shifting. Now the software developer does not have to do merely the coding. What he has to do is he has to skill himself in the emerging technologies that is based on AI. Like many of us are using Chat GPT nowadays. I myself is using for the purpose of like getting these kind of PPTs prepared very rapidly, right? Getting the solution of the numerical problems, right? To very easily. So that basically does not give you an idea. Idea is of course original. It is original. Thinking is always original. AI cannot help you in thinking, but definitely it can help you in minimizing the time and effort in implementing that idea. This is what is the actually the thing is. So when we talk about the modern engineering, as I've told you, given you an example of automotive industry, given you example of robotics, right? Similarly, there are other global challenges that are very complex nowadays, like climate change. You must have seen the government is talking about climate change nowadays. Everybody is talking about that now. The climate is unpredictable, more unpredictable. Like we don't get the rain during the rainy season, right? We don't get the proper heat during the summer season, or the hot weather has extended for major part of the year. So these kind of things are happening. So that is a cause of concern because the sea level rise, and you see that somewhere there is a lot of rain and somewhere there is not a single drop of rain. So these kind of things that is adverse. Then we are talking about global pandemics. So everybody has seen like COVID, just it has gone, right? Few years back. So that kind of pandemic is there. These are on the rise. So we need a lot of again kind of collaboration between different groups. You must have seen in the COVID, the many of the countries have come up with their this vaccines, COVID vaccines, and India is especially has tackled that thing in a very you can say smart way. They have their Covishield and Covaxin was there. So these two vaccines were there and they were exported also. We have helped other countries also. But that needed rapid action, collaborative action, and the wider scope of skill set. Just to have that kind of, you can say, the invention, I would call it as an invention of a new vaccine that is effective, and that because the time was very short. Pandemic was very, you can say, at a large scale, and the people were getting feared, they were getting died. So we need to have good, very fast emergence of some kind of vaccines. Then we are talking about sustainable energy. Government is talking about sustainable energy goals like renewable, right? So you see that when we talk about renewables, again, it needs electrical engineering, it needs electronics engineering, it needs other kind of engineering also. So multidisciplinary approach is required, right? So we have to come out of our mindset. This is just a mindset. that I am an electronics engineer, somebody else is electrical engineer, somebody else is mechanical engineer, because electronics engineer in himself cannot do anything nowadays, or computer engineer in himself cannot do anything. He has to take the you can say he has to work in collaboration with some electronics engineer, some electrical engineer, so as to create a system. Now, that's why the second point is very valid, that the siloed research means individual research, right? So isolated compartments, they are no longer relevant. And that's why you must have seen in some of the engineering colleges where lot of allied branches are coming up, like robotics and automation, right? Then it is coming like cyber security. Then it is coming like VLSI design, nanomaterials. So all these branches are coming up alongside the conventional branches like electronics, computers, then electrical, mechanical, civil. So these were the core branches, and now we are getting the other branches also coming up. So other departments are being created just to cater to this philosophy that we need to have a multidisciplinary skill set. Now, so when we talk about that how to do the collaborative research means that people from different domains, they are coming together. Like this conference is also a collaborative effort, right? Because the delegates from different streams, from different backgrounds, they have gathered at a single platform and trying to get their ideas exchanged, listen to some of the experts, some of the keynote addresses and things like that. So what is the, you can say, what could be the infrastructural requirements? The first is interoperable infrastructure. Interoperable means, like you must have seen the many of the letters from the government or from the state technical departments or the central technical department, they are coming up to the different engineering colleges. They are saying that, okay, you can use the facility at IIT Madras, you can use the facility at IIT Kanpur. So that is the basically interoperable infrastructure. So it is not possible for every college to have their own supercomputing labs or other prototyping facilities, but they can utilize it partially, right, on the sharing basis, right, remotely also, and from the different. So basically the clusters are made. So one parent good institute situated nearby, like IIT Delhi IIT Roorkee is also the central hub for so many colleges that is existing in the surroundings. Now, we can have some like dual advisors for PhD programs, cross-functional talent transfer, right? Like if somebody from your college, if I am also acting as a co-supervisor, and then definitely my expertise will also reflect in that PhD research work, and the people will have to get benefited from, you can say, cross-pollination, right? Cross-pollinate expertise. That kind of thing is happening. Now, then we need the funding also, agile funding ecosystem. Agile funding means that funding should be very fast, right? Fund like in presently, what happens is that lot of funding. See, funding is very important. Reason being that whenever you want to talk about some collaborative research, so it involves a lot of expenditure. You right, you have to keep a JRF, you have to keep a SRF. So project is very important for any, you can say, collaborative research. So you have to have fast funding ecosystem where the private sector is also being invited. Like when I was heading the department, I also thought of like having the center of excellences in our NIT campus, right? And I made a proposal also. Somehow it could not materialize, but that was my idea, that we can invite the private sector to open up some center of excellences. So we have to give, the college institute has to give the space and the equipments and the trained manpower were to be provided by the industry. So the students, the teachers, they were supposed to work on some of the very you can call it uh, their actual real-time research problem that the industry was having at its hand. So when the industries need something, so they work on at our campus, and then we could, in the process, the students and the teachers, they could get the opportunity of ha- training themselves, update themselves, right? So these kind of things can happen for inculcating the habit of collaborative research or changing the mindset, right? These kind of things. Then if we talk about high impact technological frontiers, so high impact nowadays, as I've told you, that we have to realize the systems. So we have to convert from the theoretical publications to the manufacturing or product manufacturing. That is very, very important. So some of the fields that are coming up, like I have taken some of the examples. This list is not exhaustive, right? So you can think of several other examples from your domains, but I'm just giving you an idea that by looking at this, you can have an idea that how we can think of these things like biomedical and neural engineering, right? This could be one of the technological frontiers where the material science scientists, the sensor scientists, sensor experts, and neurobiology, etc. They can go for some development of bionic limbs or brain-computer interfaces, human-computer interfaces. You must have seen, like Facebook has given the feature nowadays that you can just wave your hand and you can make your PC to work in a particular fashion. You keep on speaking, and some of the text keeps on typing itself onto a Word document. So that kind of human computer interfaces or brain, you can just think, don't make any gestures. But if you can think, then you can make a computer to work in a particular fashion. So that kind of scenario can be there. So it needs different expertise, right? Then smart infrastructure, IoT is a big way. Like we have opened in our department as another B.Tech in industrial IoT, right? That is industry 4.0, 5.0, and this is industry 6.0 is also coming up. So what IoT is Internet of Things, right? And this requires lot of, you can say, interdisciplinary approach to study IoT and even industrial IoT, right? So like some of the students are working under me, they are working on cyber physical systems. That is also a multidisciplinary domain where the people are talking about that any physical system can be converted into a cyber physical system by adding certain features. For example, your college, right, that does not have any central mechanism or automated mechanism. I don't know whether it is there or not. So sorry for that. But I'm just taking a hypothetical example. Any institute, like why I'm talking about your institute, you may be able to relate yourself, right, to some of the things that happen in the institute. So whenever you see your institute, you see that, okay, the students are attending the classes, right? So their attendance is taken, you can say, manually. Then grades are also submitted manually, right? Then other things are happening that way. But you can think of some automative things like when the students go, the door opens automatically, right? The AC turns on. Then when they leave the class, the AC is turned off. So all these kind of automations, the teachers can submit the marks online, right? They can have the online test also, quiz programs online. So that kind of thing is requires IoT basically, right? And this can system, when equipped with these kind of things, that will become a cyber physical system kind of thing. So any physical system can be converted into a cyber physical system by adding certain communications, remote accesses, and adding certain automation, some intelligence, some automation, and things like that. So these kind of things. So smart infrastructure, like you can have a bridge also where it is taking care of its health on its own. You can just put some sensors, and if the age is not proper, if it is not happening, then what happens is it will tell you that, okay, I am not feeling well, so you just repair me or something like that. I need repair and things like that, right? So it should not happen that the bridge comes down, collapses before it is being repaired. So that way we can keep track of so many things. In healthcare also we are doing robotics. I have already talked about, right? So these kind of things are happening today. Earlier also they were happening. This is not like this has not started yesterday only. This has been happening for the like several years, but now the emphasis is more on these points, right? This has become just on in front of us nowadays. Whenever you feel like, you will find that earlier it was said that we should do like this. Now it is that this is the need. We have to do, right? So this is the only difference. Earlier also there was a development on electric vehicles. Earlier also there was we're talking about the robotics and things like that. It's a very old branch. But now the systems have started appearing in front of us. That the system is actually working, right? So whenever the system is actually working, right, Chat GPT is now a reality. Earlier it was large language models. Now it is actually working in front of you. And I think every student or every person is making some use of it, maybe not like 100%, maybe say 10%, 20%, 30%, but everybody knows it now. So it has become, this is just, if I take an example, you must have heard about Alom Vilom and Kapal Bharti, right? So these two yoga techniques, they were not very much famous, but that existed for the like thousands of years back. This is our Indian tradition, right? But Baba Ramdev, Swami Ramdev, he has made it so commonplace that even now a very illiterate person or very, you can say, common man, even though he is not aware of these things, but he has heard about the term Kapal Bharti and Anulom Vilom, right? So this is that kind of story. Okay. So these things existed earlier also, but now they have become very, very commonplace. Now everybody is talking about AI. तो झक मार के हमें AI सीखनी ही पड़ेगी. अब नहीं सीखनी पड़ेगी तो साल 2 साल बाद सीखनी पड़ेगी. Okay. So this has become imminent requirement. Clear? So some of the operational bottlenecks, why the things are not happening, why the collaborations are not happening, why we are still working individually, right? Especially academics. Academicians are not very, you can say, uh, very prone to collaborations, right? They think that, okay, I am the most intelligent one, I am working independently, so why should I take the help? Why should I talk to others? Why should I take the help of others? And why should I involve others? Right? That kind of thing. So the one reason could be traced as per the internet information. There's a communication gap, right? Different persons, they are having different taxonomies. Taxonomies means nomenclature. Like I can give you a very good example for this. Like iota for complex numbers, we use iota in mathematics, right? But we use J for representing complex numbers in electrical engineering or circuit theory or networks, right? So this iota and J, they both are the same thing, right? But we are using different taxonomies. So one person working in one particular domain is not comfortable in adopting the the terms and the things from the other domain, right? So these kind of things. Then IP attribution frictions means intellectual property. Like who will get the uh, credit? Like 3 or 4 persons are working together, then maybe as a student or as a teachers also, we have been guiding some projects, minor major projects for the B.Tech students, undergraduate, postgraduate students, and there the students are working on some projects, like 3 4 students are working. So now there is always a dispute that who will get the credit for doing the particular project. So one person says, okay, I have done this thing. Nowadays, the students have started dividing the work. They say, okay, this part I have done, this part I have done, this part I have done. So that kind of story is there. So this can happens in collaboration, right? So credit allocation, publishing hierarchies, like one paper is published, whose name will be put first, then second, then third. These kind of things are there, right? So this is some of the information that I have taken from the net. Then evaluation hardships, that is also there, because if some of the non-traditional things are happening, multidisciplinary, and you're talking about some, for example, you create a system and you want to publish about this thing, then the journals may not be that, you can say, ready to take your publication. They say, okay, this is not good and something like this, right? This has been happening earlier also. And just today I was listening to one video on the internet in the morning that there was a lady, right, who invented these wipers on the vehicles. Wipers you have seen us, the mirror wipers, right? These wipers are just to like make the driving possible in the during the rain. So this was a very simple device. So that lady has designed it. She got a patent also, but she could not get it converted into the product. This I am talking about the early 90s, 1900s, right? So this is what is happening. So this happens, clear? So even though your idea is good, but that may not be taken by somebody else, right? There may not be anybody is there to buy it out, and they say, okay, it is not very good. It is not having any commercial value, but the things happen actually. Am I able to convey myself to you? Pardon? Am I able to convey myself to you? You're getting my the ideas, what I am saying to you? All those present here. Okay, very good. So this was the idea that that keeps these efforts in check. Now, I have taken a case study also. I have included in my presentation one case study also, right? Where we have, I have taken the case study of biomedical engineering, right? Just to exhibit its multidisciplinary nature. And we can see that how the different things in this particular domain needs some multidisciplinary skills, right? Like in biomedical engineering, we can have devices, we can have implants. Implants means that can be put inside the body, right? Prosthetics, the you can say the false limbs basically, then mechanical limbs, tissue engineering, biosensors. These are the things. And electronics and communication and instrumentation people, they can help in dealing with biomedical signals, wireless monitoring, IoT, and medical instrumentation. So you see that within the particular domain, this is the importance of ECE people. Then electrical engineering, they can talk about imaging, stimulation, signal analysis, medical device control, right? So this required the skills from this particular domain. Then computer science and AI support, imaging, of course, imaging analysis. Now you must have seen that earlier you must have talked about like computer tomography, CT scan. You must have seen this thing. Now you see that CT scan is, they have improved a lot, right? God forbid that anybody has to go under a CT scan, but if it happens, then you see that nowadays we are able to see the things very clearly. So sophistication things have happened, and now the doctors are looking at the things from the you can say in the real time, right? So patient data is given in the real time, and they are able to see the things and draw their conclusions and diagnose the things very easily as compared to the earlier things. And now the machine also helps because of intelligence involved, because of AI, and because of all these things. You can say machine learning, deep learning, and things like that. So health informatics is very important. You can say very major domain where the skills from the computer science and AI background helps in realizing the systems. So you see that within a very, you can say this particular domain, I have given some examples, right? So we can have medical devices and diagnostic systems like CT scan, MRIs, things like that. Medical devices like stethoscope. Now, if you look at the stethoscope itself, or you can say blood pressure monitoring system, right? Measuring system. We have got many variants of blood pressure monitoring system nowadays. Some of you have seen in your houses also, right? Some it's a very digital machine, right? Small digital machine that a single person can operate, right? In the doctors, they also have some with round dials, analog plus electronics. Some digital systems are there. So these are different kind of medical devices that is coming up because of, you can say, efforts put in by different persons. But they need, again, if you want to have a digital display, they need the electronics behind this, right? Similarly, the other requirements like prosthetics, orthotics, and rehabilitation technology, right? So all the mechanical limbs, nowadays we can have a good hearing mechanism. And just a few days back, I was reading somewhere that, of course, all the innovations nowadays, they are coming from China principally, right, in terms of products. So that was a idea from there that they have implanted something behind the eye of an blind person, and that person is now able to see the things through that particular device. Okay, so he is no longer a blind. The person who has been blind for like 20-25 years, right? He is able to see. So that kind of things are happening. So implants, artificial organs, biosensors. So wearable systems. Wearable system is another important thing, right? Like we can have nowadays, you must have seen the smart watches, like Apple Watch that you have, we wear in your on your wrist, and that shows your heartbeat, the steps you have taken, and this can display also the call that is coming on your mobile. You can link it with your mobile. So these kind of things are happening, right? But they need multidisciplinary approach. Again, my emphasis and focus is on multidisciplinary approach. Now, if you talk about electronics EC people, so I have just make a gathered this information from the net itself, and this is quite easily available. I have just make it a collection just to present my talk, right? So you see that this ECG, EEG, EMG, myography, and encephalography, these signals, lot of, like we have got a very good work on ECG signal analysis, where um, the early detection of the heart disease we have got a patent also on this, the recently granted. And this ECG, like, you know that there are the cases where the person's ECG is okay, like somebody with some discomfort in the chest, he goes to a hospital, like get him examined from a doctor, and doctor takes his ECG. He simply says that, okay, your ECG is okay, there is no problem, there may be some indigestion issues and something like that. But that person was having some issue with the heart, but it was not diagnosed properly because of some limitations. So these limitations we have improved, and we have tried to get the ECG signal properly analyzed through machine, giving you an indication that there is no false negatives, sorry. Okay. So in that case, what happens is that if a person has got, like, his ECG signal is analyzed, and if he has got any discomfort in his heart, any issue with the heart, however minor it may be, So with an accuracy of more than 99% plus, we can analyze that there is an issue with the heart or not. Of course, because this is just for the diagnostic purpose. Rest is taken to be with proper doctor and all that for further things. So with the very simple and very, you can say, cheapest diagnosis of ECG, which takes hardly 150 rupees or something like that. And there is no need of going for a test of MRI or echo test worth 5,000 or 10,000 rupees, right? For detecting a heart disease. So this was a contribution. So basically what I'm trying to say is that EC people can help in the analysis of these kind of signals. Then wireless and wearable health monitoring system. Nowadays, uh, we have got lot of systems where the like babies sleeping in some other room, small children in the house, right? And we put some monitoring system, and the parents are sitting in the next room. They are enjoying themselves, and then when the baby wakes up, so that monitoring system that raises an alarm, right? That baby has woken up, so he may not fell down from the bed or something like this. So that way, these kind of wireless and wearable health monitoring systems can be contributed towards by a ECE people or skills with an electronics and communication background. Then biomedical signal processing and feature extraction, that is quite familiar one. Then we can have, similar to IoT, we can have Internet of Medical Things, like machines communicate among themselves, right? And soon you will see that if I give you an example of Internet of Things devices, nowadays you must have seen on the internet, if you see that products are available where the mood lighting is there, right? The bulb is changing its light and that is controlled by an app on your mobile. I think you must have seen, which is known as smart bulbs, right? We can have smart sockets, smart devices. Of course, smart mobile is with everybody. Everybody knows what is a smart mobile, right? You please let me know the time constraints, right? If any, and by what time, till what time I have to speak.
5 minutes.
Pardon?
5 minutes.
Up to what time? This is 1:38.
Sir, up to 145, I think.
1:45. Okay. Right.
Yes, sir. The other speaker is looking.
So, okay, I have been given the time till 1:45. So I think I have got approximately 6 minutes or more, right? So I will just clearly wind up with the things. Otherwise, we can keep on speaking like this. So similarly, the some electrical people, how they can contribute towards biomedical engineering domain, right? This you can see on the screen. Computer science, AI, and data engineering. These again I have talked to extent. Mechanical engineering, all these mechanical devices, right? Prosthetics, surgical, and minimally invasive robotics. The robotics is playing a very good role in biomedical engineering nowadays. Chemical and materials engineering, right? All kind of drugs, all kind of you can say the delivery inside the nanomaterials, right? We are putting the medicine right at the place. So physics people, chemistry people, they are working, they can contribute here. Instrumentation and control. So all kind of automation comes under this category. All kinds of instrumentation comes under this category. So these people from this background, they can contribute here, right? Nanotechnology and photonics, fluorescence, optical imaging, laser-based medical procedures, spectroscopy, all these domains are there, right? So these things I have already talked about. Medical imaging and AI. This is a very good domain. People are working, and you are getting a lot of publications available in this domain. Then this is medical devices and instrumentation. So what I come to now is this thing. This is very important. So emerging interdisciplinary research areas like AI plus biomedical engineering, right? This could be one area. ECE plus biomedical engineering could be another area. IoT plus healthcare, robotics plus biomedical engineering. So I am just putting a focus on biomedical engineering, right? But this similarly we can have in other domains also, cyber security and medical IoT, right? This could be one domain. So for an engineering institution, interdisciplinary laboratories, interdisciplinary branches, that is the need of the hour, right? We can have wearable and IoT based healthcare prototypes. Then we can have research groups on medical imaging and AI. Then we can have robotics and rehabilitation. So basically what I want to say is that all these kind of research groups can exist and they should be, right, for any engineering this thing. So like EC, electrical, mechanical, chemical, material, they in the engineering foundations, these people can contribute. Computational layer requires CSE, AI/ML, data science, and signal processing capabilities or skills. Like technology layers require these kind of skills, biomedical layer, then clinical translation. So basically these kind of skills that are required. So all these branches, they can contribute towards biomedical research gap. So if I say what is the path forward, that is the industry convergence, right? So first thing is that the in universities, colleges, they should basically give the incentives for the people to working in the interdisciplinary branches so as to get them good promotions and things like that. So these things will definitely be incentivized, will be given incentives. Then open source collaboratives. Nowadays, a lot of open source repositories are there on the internet. Code bases are there. Hardware projects are also there. So these kind of things will be able to further give the boost to the multidisciplinary skills. So the final outlook is that nowadays we need T-shaped professionals. What do you mean by T-shaped professional? So when you see the T-shaped professional, this T, the vertical branch, shows the specialization in a particular domain, and the short horizontal T, horizontal part of this T, that indicates the skill required in other disciplines also. So nowadays, you cannot do this with the specialization only in one domain. You have to acquire the specialization or some expertise, a minimal skill set from the other domains also, so as to keep you relevant in the job market and keep you, you can say, employable, right, or relevant in the emerging technological domains. So I think I have like hushed up with my presentation given the time constraint. So now I may ask some of the like queries if anybody is going to ask it from the audience.
Anybody want to ask any question to Dr. Vikas sir? If you have any doubt or any questions, you can ask your question to Dr. Vikas sir. He is waiting for your questions.
I think I have been able to convey my idea. So
Hello.
if it excites you, then I may like I am looking forward to some of the queries from your side.
Pramod sir. Pramod sir. Hello.
Anji, yes. Yes, please. Any query or yes, yes, please.
Hello.
Answer.
Sir, am I audible, sir?
Yes, yes, you are audible.
There was some disturbance, sir, with the people. Now we are again connect. Students are very satisfied, sir, and first and foremost, I would like to express my sincere gratitude to you, sir, for taking the time to be us and for sharing your such valuable insight into the rapidly evolving field of artificial intelligence and electronics, sir. Such it was really, sir, very beneficial session from your side. I would like to say thank you so much, sir. Your thoughts on the convergence of AI intelligence systems, embedded technologies, automation, and next generation electronics, whatever you have given to us, sir, have given us a deeper understanding of how these technologies are transforming industries and shaping our future, sir. So I would also very thankful, sir, and our organization is also very thankful with faculty members, coordinators, volunteers, and technical teams. They are very thankful to you, sir. You have given your precious time with us, with our organization, for our students, sir. Hope so. Okay, we will again very soon. We will connect with you, sir, in next coming conference, sir. So thank you, sir. Thank you so much, sir.
Okay, thank you very much. My mail ID is available on the website of NIT KKR, right? So my credentials are also there. So if anybody like to connect with me, then please. Okay.
Sure, sir. Sure.
Okay,
Sure.
okay. Thank you. Thanks a
We will
lot.
connect this message to our students also, sir. Thank you so much, sir. Once again.
Can I leave now? Can I leave now?
Yeah, yeah, sure, sir.
Yeah.
You can leave.
Okay, thank you. Thanks a lot.
Have a good day, sir.
जो भी लंच लेके वो लंच कर लिया टॉक्स होगी तो लंच के बैठ सुन सकते हैं टॉक को कंटिन्यू कर सकते हैं लेकिन जो लंच लेके वो जाके लंच कर लेंगे बीच में नहीं निकलना है किसी को जाना है तो चले जाओ जाना है तो आप जाइए
AIML second year students क्लास में जाओ सभी लोग AIML second year students क्लास में जाइए नमस्कार AIML second year